Okay, welcome back to video number 2 for unit number 1. Last time I left off talking about homeostasis and how it was a means for us to maintain an internal body temperature, and some of these homeostatic reactions are controlled by feedback systems. So let's have a quick talk about feedback systems. Now, a feedback system is generally going to involve three different things: a receptor, a control center, and an effector. So our receptors are structures that are all over our body, and it monitors the situations of our body, and it monitors basically everything. It can be blood composition, it can be blood pH, it can be glucose levels in the blood, and that's just talking about the blood. We can also talk about levels of water in the body, so on and so forth. So we have our receptors, they monitor the body. Then we have our control center, which is most likely the brain, although it can happen in the spinal cord in some situations. But the control center monitors everything that's happening in the body, and it sets limits on things. So our body operates best in a certain range of conditions, and our brain, in order for homeostasis to work, our brain will focus on maintaining our body in those set of normal conditions. So the control center receives all this information from the receptors, and it makes decisions based on the condition of the body. The effector is some structure in the body that will take direction from the control center, from the brain, and cause a change that will help get the body back to that normal range where it works. So these three things work together to give us our feedback system. So let's have a generalized example of how these feedback systems work. All right, so if we look at this picture right here, you can see if we start down here, we get our stimulus, and this triangle right here, and the little, we'll call it a block that's balancing on it. When it's staying straight like this is when the body is in homeostasis. That's staying normal. Now, if we get an imbalance, we can have that tip up or we can have it tip down. We don't want it to be like that. We want it to come back to the straight level position. So if we get some stimulus that causes a change to imbalance that homeostasis, then we get that information detected by a receptor, and that receptor sends that information to the control center, which is usually the brain. From there, the brain is going to send an information to an effector, and that effector is going to cause a change that'll hopefully correct that imbalance so that we get back to a level position. Okay, and that's a generalized function or generalized example of a feedback loop. Now, we can be a little bit more specific. We can have different types of feedback loops. We can have positive feedback loops. And in this case, when we get a stimulus, the reaction that the body has is to increase or reinforce that change. Now, this isn't something that happens very common. Okay, we don't see this very often happening in biological systems. Generally, we see the negative feedback. That's more common. But an example of a positive feedback situation is childbirth, for example. A stimulus, the woman's body creates a stimulus, it's sent to the brain. The brain releases chemicals that cause the contractions of the uterus to get bigger. And those contractions result in the child being born. Now, those contractions build up until the child is exited the body, and then that external mechanism is what shuts off that feedback, or sorry, that change in homeostasis. It's not a negative feedback loop, which is like I said, the more common one. It's the positive one. So we're not going to go into too much more detail about the positive feedback loop, but we will focus on the negative. Now, in a negative feedback loop, we're going to see a reverse a change in a controlled condition. So this is much more common in biological systems, and the general idea is a change in the homeostasis occurs, and then that change is corrected and returns us to normal conditions. So we'll use an example here of the blood pressure. Okay, so we'll have a look at our negative feedback loop, and we'll use the blood pressure as an example. So if we look up here, we'll have our stimulus. Something happens, and that causes our blood pressure to increase. That's picked up by receptors, and in our blood, in our cardiovascular system, we'll have receptors called baroreceptors. Now, baro refers to pressure. So these receptors are specialized to detect pressure in the blood vessels. So these baroreceptors report back to the brain, and they say to the brain, hey, you know what? According to these receptors, our blood pressure is higher than it normally should be. We need to do something to correct that. The brain interprets that signal, and then it sends an information from the brain, the control center, to an effector. Now, in this case, the effector is going to be the heart. The heart will, from the direction of the brain, slow down the pumping rate, and as a result of that, it decreases the blood pressure. So what happens here is the heart affects a change, and then that goes back and it decreases the initial change that happened from that external stimulus. So that's an example of a negative feedback loop, and we call it negative because what it does is we get a change and then something happens in the body to make that change go away, a negative reaction. So that's an example of a negative feedback loop. The rest of this unit is talking about anatomy, and one of the things that we need to understand well when we're talking about anatomy is basic anatomical terminology. So what are anatomical terminology? Why do we use it? In what context do we use it? Understanding anatomical planes, sections, and directional terms, and understanding regions of the body. These are all important concepts to know and master before we start learning about specific structures and so on and so forth. So for the rest of this unit, we'll be talking about anatomical terminology and how to recognize it and how to use it effectively. So this figure here shows two different models, and it's showing you a list of words, and these are words that were going to be really important for us to understand as we move through and talk about anatomy. So you can see the word right, left, proximal, distal, medial and lateral, superior and inferior, anterior and posterior. These words all work in pairs, and they're all contractions, though they're opposites of each other. We'll go into more detail, and I'll give you examples of that as we keep going. But first of all, there's a really important concept we need to talk about, and that's called anatomical position. So in order for us to use any of these anatomical terms, we need to have the body in an anatomical position. Doctors will use this for surgeries in most cases, unless they have to do something different. Whenever a body is being autopsied, for example, after people die, they're always done in anatomical position, and that's done so that we can relate the body position and different things that may have changed or may be different from normal. So the anatomical position is when the body is standing upright or laying down on its back. The head is level and straight, facing the observer, or facing forward. Eyes are facing forward. Feet are flat on the floor. They're not pointed, but they're flat. Arms are at the sides, and the palms of your hands are turned forward or turned ventral. Alright, so after we have the body in anatomical position, now we can start learning these directional terms. And the reason we call them directional terms is because they give us information about the direction we're talking about on the body relative to another body part. So if we have a look at these, you can see that they're usually grouped in pairs. So we've got anterior and posterior, superior, inferior, medial and lateral, and proximal and distal. Okay. These work opposite of each other. So these are the 8 directional terms that you'll need to understand, and the next few slides we'll go through them and I'll give you some examples. So anterior, posterior, really quite easy. Anterior is going to be the front of the body, facing the front, so the face. Posterior is going to be the back. So if you look at the arrows, it's a pretty simple way to tell stuff. Anything on the front part of the body over here is going to be considered anterior. Anything back here is going to be considered posterior. So if we look at the examples of the skeleton here, on this side we've got a skeleton facing anterior, and on this one we've got the skeleton facing the posterior. So simple terms to use, but understanding them and being able to use them correctly is key for anybody who's dealing with anatomy. The next one is superior or inferior. Superior refers to above, and inferior refers to below. And it's always a relative term. So if we're talking about the eyes, for example, we can say the eyes are superior to the mouth because the eyes are above the mouth. If we look at another example here, if we think about the internal anatomy, the stomach, of course, is located below the heart. So we would compare that. We would say the stomach is inferior to the heart. So superior means above, inferior means below. And we use those, as always, with a point of reference. So we use it to compare. Medial lateral, now we're thinking about the midline of the body. So we're talking about, the line that goes through the chest and the abdominals. Anything that's lateral is going to be away from the midline, and anything that's medial is going to be towards the midline. So the heart lies medial to the lungs. We have our lungs on the lateral side, and we have the heart in the middle, so we say that's medial. Lateral would be towards the outside. So if you think about the body in anatomical position, hands at its sides, palms facing out, the thumb is going to be lateral. Okay, it's going to be away from the midline of the body. Proximal and distal. Now, some students have a bit of a problem with this one, but let me try and make it a bit simple. Whenever talking about proximal and distal, we're always talking about the point of attachment or to the trunk of the body. So if we're talking about something on the arm, think about the shoulder as a reference point. Anything close to that shoulder is going to be proximal. Anything that's further away is going to be distal. Okay, so if we talk about the wrist and the elbow, well, the elbow is proximal, the wrist is distal. So they're easy to use, but you need to remember that you always keep a point of reference in mind. So on the arm, we're going to be talking about the shoulder, and if we're talking about the legs, then we'll be talking about the hips. But we can also talk about this in terms of hands or anything like that. So keep those options in mind when you're thinking about these terms. All right, the next thing we're going to talk about are planes and sections. You guys have been to the lab and you've seen slides before. You know that we often cut stuff so that we can put it on a microscope, and we can have things like cross sections, for example. Well, that's exactly what we're talking about here. If you look at the example on this slide, you look at the horizontal or the transverse plane, that's going to be an example of a cross section. Oftentimes when we're doing anatomy lessons or anatomy studies, it's important for us to know if we've got a structure like an organ, for example, how it's sectioned. Did we cut it in what direction did we cut it in? So the body has three principal planes. Includes the frontal, the sagittal, and the transverse sections. And here's an example of all three of them here. The first one, the pink, shows a sagittal plane, which is split down the middle, so the body is divided into a left and right half. The middle one in the green is a horizontal plane, and that cuts the body at any 90-degree angle to the midline of the body, the central axis. So we get a superior and an inferior. And then we have the frontal plane, which cuts the body in half so that we get an anterior, or the front part of the body, and the posterior, which is the back.